Okay, AI at Facebook, I wanted to cover briefly because often people do ask me, what does Facebook have to do with AI? Like, why are they connected to it? It's more obvious why Google does AI, but Facebook, it's not obvious. So one of the things we do is in the Facebook app, there's a lot of recommendations, social recommendations, and also um, like if you're just texting friends for particular restaurants or you're looking for like a barber, generally there are suggestions that come up, and then there's all these auto populating of oh, that restaurant, yeah, it's rated this much and it has these many followers. Those are the kind of things that we use AI for to predict contextual information in conversations. And the other thing is, one of the biggest application is machine translation. If you've had friends who don't speak your native language, you might have already used and seen this feature where someone actually writes a status update in one language, and it knows which language you are comfortable with, and it actually can automatically translate that into your native language. Um, and it's one of our biggest services across like tens of languages, I believe, with a ridiculous number of predictions per day. And lastly, one of the more important things that I personally find very interesting is we actually have in-app accessibility features that I think are very cool. So if you are if you if you can see very well and you actually want to use the app, in general, almost all apps, they do have a feature to where you tap parts of the app and then it'll read out the text to you. But we have more additional things, such as you can actually tap on images in the Facebook feed, and then it will actually read out to you what the image contains, which seems nice. Like, you can actually then relate to what your friends posted, not just by the caption they put, but also like what's going on in the image. And we also have like new experiences that are pretty much AI driven. Like basically, if you have a page, you're running a business, you can have a bot assist you with replying to people in live chat and automating part of the process for you. And also like classifying and generating content like headlines or like formatting, I believe, not headlines, but and you've seen this in the Instagram app. Lots of cool AR effects, like, you know, applying masks to your faces, or also like just putting a particular virtual object in the real world and then sending that to your friends. And then lastly, Oculus is one of our bigger products, where it's this virtual reality gear where you wear it and then you can just live in this alternate world, even though sometimes it feels dizzy. And it's pretty cool to play games and also to talk to your friends in VR rather than in real life. How cool is that? And lastly, one of the biggest investments we've been making, and it's almost essential that we need AI as a component here, is helping protect the community. A lot of reviewing comments and content goes through a particular pipeline where part of it is AI, which can filter out more of the high confidence things that it can predict. And then lastly, we did talk about a bit in the past about how we also automatically try to flag situations where people might be giving out suicidal expressions, and then try to prevent that as well. So we actually like if we detect such a thing, we actually try to pop up something where you can automatically contact a helpline or talk with a friend, and also just see some tips online. So that's Facebook and AI. It's not what I talked about is not a complete picture. It's just a snapshot of the various programs we are doing. I work at one of the divisions in Facebook AI that does more of the fundamental research. So things like inventing new techniques in deep learning, maybe a new cost function or a new particular type of neural network layer, things like that. And I also work, and Facebook has a heavy emphasis on these three general areas: reinforcement learning, computer vision, and natural language processing. Now, I actually wanted to take a step back from Facebook and also from AI, but just talk about tooling for a second. This is a machine learning conference. You guys are all machine learning practitioners. At some point, you probably use scikit-learn. So you probably read a documentation page like this. It says like scikit-learn.cluster.k-means, and it's this nice prepackaged algorithm that's available to you in one line of code. It has lots of options. One of the things that I wanted you to sort of reflect upon is think about what you would do if this algorithm was not available to you in this prepackaged way. The delta between this being available and you implementing it is pretty large. You probably have to implement it yourself. Maybe it'll take like a few hours, but then you might have to make it more efficient, which might take a few more hours or maybe days. And then you might actually have to then implement all the options in there and then find what are the reasonable defaults for each of these options, right? So my take on this is if these prepackaged algorithms are not available, you very likely will use other prepackaged algorithms and simply skip the idea in your head that says, oh, I want to try k-means. Then you probably will be like, oh, but it's going to take 3 days to do the whole thing. I'd rather just like push this through like I don't know, like another algorithm that I have, even though I know it's suboptimal. Like I have a cool idea, but I don't think I want to invest the time and energy into it. And this is actually a very common occurrence. But actually, the other thing to think about is not so much as what are the prepackaged algorithms that I have and what I can use, but have you considered how your work is biased by what's available to you? So even like if you just want to use k-means, right, and you have scikit-learn, you only have a certain set of options. What if you want to try something different? You want to maybe randomly initialize in a way that's not determined by whatever options they give you. It effectively creates a bias in your working relationship with your machine learning pipeline because of the tools available to you. So actually, like the tools heavily shape what you want to do and what you don't want to do. Unless you're just mad and you spend like a year implementing everything you want, right? So this is something that that has also been driving deep learning. The tools themselves are heavily shaping what people will and will not do. Like the most popular frameworks in this space are TensorFlow and Pytorch, and it almost often happens that a big chunk of research depends on whether a particular expression or a mathematical idea can be expressed in these frameworks. So one of the critical things that me as the developer, one of the developers of Pytorch, or generally like the people who are building tooling in this field can do is to try to make the framework as flexible as possible so that you can express all the ideas you want and you're not limited by what the framework gives you, but you're limited only by the ideas you have. Like that's actually like one of the biggest factors I feel like that determines progress in machine learning as well. The tooling itself limits you and might also change the way the field moves. And this is also one of the reasons why every X years, the new tooling appears. So as the field changes and moves in a particular direction, the tools that you were using are no longer as relevant as they were before. So before Pytorch, I helped build this tool called Torch, but it only helped, it helped do a particular set of neural networks really efficiently, but those kind of styles were going out of date, and you wanted to move to like more flexible, more different tooling. So it's pretty important to also keep up to date on what new tools are available, because that also determines what you can do most efficient. So that's one of the important points I wanted to make. And then the rest of the slide is me talking about Pytorch itself, how we built it, what it is, and why we built it that way, and some of the newer features we have. So Pytorch itself, if you actually look at it broadly, it has 4 components. It has what at its core what we call an automatic differentiation engine, where you use it like NumPy, but you can differentiate any part of whatever you computed with respect to any other variable. And then below the automatic differentiation engine, we have an NDR library with GPU and soon TPU support. And this is similar to NumPy, but it also works on not just on the CPU, but on the GPU and other accelerators. And then we have an optimization package if you want to do gradient-based optimization, and also some utilities to do the most important things like data munging, data loading, efficiently processing data. So the NDR library is very similar to NumPy, MATLAB, maybe R in some sense, and it has a wide variety of operations. Primarily, the reason people use it most is because it has really fast acceleration with NVIDIA GPUs. And just to give a contrast, the code in Pytorch or NumPy look very, very similar. They're just same program side by side. One is in NumPy and the other is in Pytorch. And you can do things like construct tensors, print the sizes, do advanced indexing, draw random numbers, do mathematical operations. And then you can also, we have a strong NumPy bridge, so if you're a NumPy user, you can convert your arrays to Pytorch and vice versa in almost like a free cost. Like it's very efficient, and there's no actual memory copy going on in the back end. So one of the nice things about this is you can actually write part of your pipeline in NumPy, part of it in Pytorch, and you can interchange between them. So you might actually take the output of a neural network coming out of Pytorch and then like throw it into like a scikit-learn SVM. And as I said, all operations in Pytorch, you can also run them on the GPU by simply casting the tensors themselves. And secondly, we provide a package for neural networks because they seem to be special these days. The way we do it is we have a simple model, simple mental model, where in the constructor you declare what parameters and layers you want to use. And the forward function, this Python function itself, determines what your neural network is. So your neural network is not determined by like some like layer set of layers that you're processing in a sequential or some pattern. It's literally this Python function is your neural network. There is no difference between the Python function and the neural network. And I think that opened up a lot of flexibility. This programming model itself is now getting popular, and it opened up a lot of flexibility that was not really evident before. And then we have an optimization package, as I mentioned. Again, it implements SGD, AdaGrad, and stuff. We also have distributed training. So if you end up somehow inheriting like hundreds or thousands of GPUs and you're really lucky, then you can actually use Pytorch to train with all those GPUs your giant neural networks. And it's efficient. We actually optimize it for all kinds of network hardware. And the style of distributed communication we have, it's called MPI. It's just a traditional programming model. But more practically, let's say you have a neural network training loop in Pytorch, and you want to do a very common pattern of parallelizing your models called distributed data parallel. You just have to add one extra line, rewrapping your model in this distributed data parallel, and then it can scale up to as many like CPUs and GPUs you have. And the performance actually scales pretty well. Here's a pretty graph which shows that we can scale up to 64 nodes with almost linear speed up, where like ideally it's as if you're running the whole thing in parallel and you get 64 times speed up, and then we get something close to like 60 times speed up or so. And sorry, there's a bit of a lag, 1 second. Okay. So one of the mental models you can use on like what Pytorch is and how to use it is, you have a lot of general work items where when you're building your machine learning pipeline, you can actually see Pytorch combined with Python as one environment to deal with all of this. You can use Pytorch for your neural networks, you can use NumPy for your data loading and munging, you can use pandas, you can use our efficient data loading pipelines to multi-process it and like use all the CPUs you have and so on. The other thing is we have a new concept called JIT. I am actually running out of time, so I will power through it. But the basic concept is, instead of just code equals model, you actually have code equals model equals data. That is, we have a function annotation that we have available that actually lets you turn your model itself into a graph that you can export and run anywhere. And you can also do like ahead of time analysis to make your Pytorch code much faster than before. And the idea is we have eager mode and then we have script mode, where the script mode is enabled by function annotation. And it's easy to take things from research to production using this mode. So you can actually write your pipelines and then export it directly into a C++ only runtime and ship it to prod at scale. So that's a rough idea. And then I just wanted to briefly power through and say, give highlights to a bunch of ecosystem projects. You heard about Bayesian neural networks. Pyro in the last talk. Pyro is a package on top of Pytorch that can do this really well from Uber. GPytorch does Gaussian processes. We have high-quality open-source machine translation toolkits, high-quality NLP toolkits from Allen AI, and various packages in the community to reproduce state-of-the-art results of various kinds. And the last one I wanted to cover was Medical Torch, which lets you do a lot of medical imaging stuff and pump them through Pytorch neural networks. Well, you can get started with Pytorch using our website or using our cloud partners. And I wanted to say thank you.